one period of cotangent is going to be this. So this shape right here. So what do y'all think? It's still pi, good. And then the amplitude is also none. All right, so we just used the unit circle and doing y divided by x, or y times the reciprocal of x, to get the tangent graph, which is what's in pencil. And then the reciprocals to get the cotangent. So let's fill in our last block on this. So the only thing we haven't talked about is the period of tangent. So what do y'all think you do? Pi divided by the absolute value of b. So if x has a coefficient, then it is going to affect the period. It's going to make it longer or it's going to make it shorter. But for tangent and cotangent, you do pi divided by that coefficient, not 2 pi. Because tangent and cotangent have shorter periods. All right, so go ahead and find the note sheet from yesterday if you haven't already. We're going to finish the back of it. Alright, so we're going to start with the first period of tangent. And it is definitely the oddball in all of the rest, compared to the rest of them. So on all of the other trig functions, the starting point is 0. That's the beginning of the period. Tangent works out just a little bit differently. So the x-intercept of y equals tangent is at 0, and we just saw that when we put in the angle at 0, we got 0. So that's a little different. So that's going to be the middle of the period. All right, so we're going to apply the phase shifts to the x-intercept. All right, and then that's going to be the middle. So to get the two, like the starting and the end, what you do is you add half a period to each side of the middle point to get your starting and your end points. And these starting and end points are vertical asymptotes. Okay, so tangent is the weird one. It's just a little different than the rest. All right, cotangent is more similar to the other ones we've graphed. So the starting point of your period is going to be at 0. That's going to be a left vertical asymptote. And so we're going to make sure we apply the phase shifts to the left vertical asymptote. All right, and then to find the ending point, we're going to add the period. To find the right vertical asymptote, which is going to be ending. And then directly in between the asymptotes is where you have the x-intercept. So we just find halfway to get the x-intercepts. Now, one thing to keep it straight in my head about which graph is tangent and which graph is cotangent, because they look very similar, is I say that tangent is a happy graph. Because it's always going up. So always positive slopes. But tangent does get sad sometimes if it's negative. So if there's a negative tangent, it's a sad graph. A positive tangent is a happy graph. All right, for cotangent. Cotangent is a sad graph. So it's always negative slope, always going down. However, if something negative happens, it makes, or cotangent is sad. If something negative happens, cotangent is a happy graph. You guys know those people. Bad things happen, makes them happy. Live on drama. That's cotangent. All right, there's one more thing. I didn't used to talk about this, but I saw a question that you would have to know this to get it right. It was multiple choice, and there were two tangents, and one was deeper than the other. And you would have to know this. So I wanted to start talking about the steepness of these. So what we normally call A, which is the number in front of the tangent, or the number in front of the cotangent, that affects the steepness of the graph. So we're going to say A affects the steepness of the graph. And we're kind of in a habit of labeling that on our y-axis anyway, because normally it's the amplitude for your sine and cosine. So we're going to go ahead and label it on our graph, and then I'll kind of show you what to do with it. So we're going to label A on the y-axis. Okay, so let's go ahead and do a few of these graphs. So for number 3, looking at that one, do you guys think this is going to be a happy graph or a sad graph? This is going to be a happy graph. All right, let's find the period. So when we're doing the period of tangent and cotangent, we take pi, and we divide it by the absolute value of the coefficient of x. So the period of this one is pi over 2. Does this one have a phase shift? No. Okay. So if there is no phase shift, if we're talking about tangents, the middle of the period, or the x-intercept, is going to be at 0. All right, and then to find the starting and end, which are going to be asymptotes. We're going to add half a period on each side.
Oh, wait. Okay, never mind. I thought you were. Sorry.
That's okay. So what is half of our period? Pi over 4. So we would take 0 and we would move over pi over 4 to the right. We move over pi over 4 to the left. So let's do that. Let's go ahead, just like we always do on trig graphs, and draw kind of a long x-axis. Now I'm going to write some things over on the right side, so I'm going to leave some space over there. Alright.
I didn't get all of them.
To each side of the the x-intercept. You're welcome. Alright, so this is going to be a little different. I'm not going to put that in the middle. We could, but I'm not going to. Okay, so I know my x-intercept is going to be at 0, and then if I add half a period to the right, I'm going to get pi over 4. And if I add it to the left, I'm going to get negative pi over 4. I guess we're technically subtracting it on the left. Okay, those two, the beginning and end of the period, are vertical asymptotes. X-intercept. What else is at 0? The y-axis. Alright, and then what's normally in front of tangent or cotangent or whatever is going to affect the steepness. So I do want to put that 1 and -1 on my y-axis. Now for tangent, these are all the points I'm going to label. Now, I'm going to just put a little mark here and here. And we could find that if we wanted to. I typically don't make my students find 5 points for one period of tangent and cotangent. We usually only do 3. But this is going to be a happy graph, so we're going to start down here and go up. But I want to just put a little point right here. At -1 right there in the middle, and then right here, just to kind of help guide me whenever I do my graph. Alright, so then I'm just going to draw a happy graph that's increasing all the time. Positive slope all the time. It's one period of tangent. Alright, so you guys know we have to do 2 periods, right? So I put it kind of over on this side just because it's a little easier to work with positive numbers than negative numbers. So I'm going to find a period to the right of this one. Alright, so I'm going to take pi over 4. And what do you guys think I need to add to it to get the end of my second period? However, so you want to add the period. Alright, so we're going to need, obviously, a common denominator. Alright, so my second period is going to end over here at 3 pi over 4. And the beginning and ending of a tangent and cotangent period is a vertical asymptote. Alright, and then my x-intercept is going to be in the middle. So to find the halfway between these two, I add them together and get 4 pi over 4, which is just pi, and then take half. So pi over 2. Alright, that's going to be my x-intercept. Alright, and then just for a little bit more guidance, I'm just going to put a tick mark there. I'm not going to find those points. but I'm going to put a little dot here, here, to help guide me. There's my second period. Now tangent, I would say, is probably the one that more of my students mess up on than any other. And it's just because the 0 is not the start of the period. And it just gets confusing because in all the rest of them it is. Okay, let's do another one. Let's do a cotangent graph. So is this cotangent graph going to be happy or sad? It's going to be a sad graph. What is the period? Pi. Does this one have a phase shift? Yes. So this phase shift is going to be pi over 4. Which direction? To the left. Okay, so that makes the starting point of my first period negative pi over 4. And for tangent and cotangent, the starting and ending points are vertical asymptotes. Alright, what are we going to do to find the ending point of the first period? Add pi to this. Add the period. Okay, so we're ready to draw our x-axis. Now on these, I kind of build from the left. So I'm going to put my starting point here, my ending point in the middle. And I know those are going to be vertical asymptotes. I also know that directly in the middle of those is going to be my x-intercept. So I need to add them together and then take half. And I think that is my x-intercept. All right, do we know where the y-axis is? We do. It's right in between these two, so I'm going to go ahead and draw it. Okay, and then what do I need to label on my y-axis? 2 and negative 2. So even though I'm not drawing these to scale, this one should be steeper than the one we just did. Alright, and then we said this is a sad graph, so it's going to start at the top and work its way down. So I know I would have a point here at 2, and then a point here at negative. Okay. So then we'll draw a side graph. Yeah, I did that pretty good. All right, you guys find that second period on your own, please. hope you guys can see the pattern just to figure out this one, because you're just doing like the next odd integer up over 4 to get it. That is your x-intercept. I'm just gonna put a little tick mark at the halfway, so I'm not gonna find what they are, but I'm gonna add a point on my curve to help us. Those two periods cotangent. Okay, we're gonna do one more together. Okay, so you guys figure out happy or sad on your own, period on your own, phase shift on your own real quick. Okay, so normally on tangent, the x-intercept, or the middle of the period, first period, is at 0. But this time, that middle has been shifted pi to the right. So that's going to make the x-intercept of one of our periods be pi. Right, and then the starting and the ending are your vertical asymptotes. And so from the middle, you're going to add half a period on each side, or really subtract and add. So half of our period is pi over 2. So we're going to take pi and go ahead and subtract that for the left side, and then take pi and add that for the right side. So pi minus half a pi is half a pi. And then pi plus half is 3 pi. Now I'm just going to make a decision. Because these are on the right side, this time when I do my first period, I'm going to have it be a right end period. And then when we find the second one, we're going to find the one to the left. Just because I want the y-axis to be in our graph. It's not a super big deal. If you do one on the right, you just would have to, I don't know, just add the y-axis somewhere on the page. So I'm going to have this side over here be 3 pi over 2. The middle be pi. And then the left side, what is it? Be pi over 2. Make a little tick mark at those little halfways. Now you guys said this was sad graph, right? Mm-hmm. Okay, a negative tangent is a sad graph, so I know it's going to be falling, it's going to be coming down everywhere. I don't have my y-axis yet, but I'm just going to estimate. I'm going to put 1 right here. I'm going to put negative 1 right here, just so I can get a good curve. Now we could wait and draw at the end if you guys wanted to. That doesn't look great. to find my other period, I'm going to go to the left. So since I'm going to the left, I'm going to take pi over 2, and what do I need to do? Subtract the period. So what do y'all think? Pi over 2 minus pi? Negative pi over 2. Good. Alright, that's going to be a vertical asymptote. Alright, my x-intercept is going to be right in between those, which also happens to be 0, which also happens to be your y-axis. Go ahead and label my y-axis with 1 and negative 1. And put my little guide points. Alright, and then I'll draw a side graph. Alright, any questions? You guys want to say hi to Braxton and Luke? What?
On the x-intercept thing, why did we not get up
When? What?
the x-intercept?
Uh-huh.
Why did we not use that on 4 to find the
Okay, because cotangent, the starting of the period is at the vertical asymptote. On tangent, the start of both of them, okay, let me say that again. On cotangent, 0 was a vertical asymptote. So that's the start of the period. For tangent, 0 is the x-intercept. So we have to use 0 in a different way. So tangent's the only one where original graph 0 is not the start of the period. The start of the period is actually at negative pi over 2. So 0 is just easier to use for the shifting. So go back, you can look at this. So for the first period tangent, the x-intercept or the middle is at 0. So we have to apply the phase shifts to the middle and not the starting. Alright, any other questions? Okay, so your assignment is a worksheet. I'll hand it to you in just a second. Now, I didn't write this on the board, but I'm going to. This lesson 4-6 worksheet is going to be another actual real grade, not just a stamp. And I'm going to have it be due on Thursday. Now, we will do a lesson tomorrow, and we'll have another assignment, but this one I really, really want you to do. I want you to do all of them, actually.